Hi everyone. In this given problem statement of JumpGimp, we are going to given an integer array nums. We are going to be initially positioned at the array's first index, and each element in the array represents the maximum jump length at that position. Return true if we can reach to the last index, or false otherwise. Now if I take this example, which is, let me change the pointers. Let me take this example. Initially the value is 2, 3, 1, 1 and 4. Now from 2 right, I can make from the first position right, I can make jump 1 or I can make jump 2. So I can either jump here or I can either jump in this direction. Then from 3, I can make a jump directly to the 4, reaching to the last index, or I can make 2 jumps to 1 and this other one. Similarly here I can make another jump, and from here I can make another jump. So we can formulate an entire tree graph with this type of directions, and in order for us to optimize the code, we have to do a dynamic programming. We have to add some memory cache in order for us to do it, just to check whether can we reach to the last index. But doing this is going to take a lot of time. So now the question is that can we try to solve this problem in big O of n? So in order to do it, we have to apply greedy approach. So how to do it? So let us again take this example. 2, 3, 1, 1 and 4. So in this example, can we set our goal to this one, this initial pointer? And if we're able to reach here, so from this point, can I reach to the last index? Can we do it? So let's say our initial value is 1. So can we from here, can we reach to this 4? Answer is that if I make an 1 jump, I can reach to the last index. So it is correct. Now if I have to shift the goal back from this one to this one, now from this one, can we reach to this value? Answer is correct. Then if we shift our goal back to 3, so from here, can we reach to this pointer? Answer is again yes. And then from 2, can we reach to 3? So in this way, can we do that? And it would be a very straightforward thing. So now here, for us to make it work, so we have to initialize a variable, let's say goal, which is going to be length of nums minus 1. Now we have to write a for loop. So for I in range of length of nums minus 1, because we are doing from back to front, so our direction is going to be this. So we are going to take this index first. So minus 1, we want to go to the last step, so our end index is going to be minus 1, and the steps is also minus 1. Now our question is that if I plus nums of I is greater than equal to our current goal, in that case the goal is going to be shifted to the left side, or I can say the goal is going to be I. If by doing this pattern, if we're able to reach to the last position, or in our case the first position or 0th position, so if goal equal to 0, we can say it's return true, else return false. So let us take this example. So let us initialize the value goal, and now right, our length was 5, so our goal is 4, and Now we are running this check. So our value is starting from 4. So 4 plus nums of I, right, which is 1. So it is 5. Is 5 greater than 4, which is correct. So our goal is keeping on 4. Now our goal got shifted to one direction, to this direction. So our goal is going to be 3. So now, right, I is going to be 3. And here, right, can we check that from 3, right, let's say this pointer, right, it is at the third, sorry, I made a mistake. It was not going to be 4th position. It is actually 3rd position, because index is starting from, our initial goal was 4. Now, right, so third, 3 plus 1, is it greater or equal to 4, which is correct. So our current goal is going to get shifted from 4 to 3. Now we are going to second position. So 2 plus 1, is it greater or equal to 3? So it is correct. So our goal is again going to get changed to 2. Now 1 plus 3, is it greater than 2, which is correct. So the value would be 1. And at last, is 0 plus 2 greater than 1, which is correct. So our goal is going to get shifted to 0. Now we can take another example, which is 3, 2, 1, 0, 4. So here, right, our goal is 4, and we are looping through. So if we're looping it, right, so our value is 3. So this check, right, I plus nums of I, is it greater or equal to goal. So here the value of num I. So let me check it out. So ith value is 3 and num I is 0. Is it greater or equal to 4, which is not true. So our goal is still going to be at 4. Now let us go back and from I, right. So now our I value is 2. So 2 plus 1, is it greater or equal to 4? Not true. So our goal is still at 4. Now it is 1. I value is 1. So 1 plus 2, is it greater or equal to 4? No. So our goal is still at 4. And 0 plus 3, 3 is the value. Is it greater or equal to 4? Which is not true. So in that case, goal is still at 4. And that's why we're going to return false in this case. I hope it makes sense to you. This is a greedy approach of solving this problem. And because we are going to loop through these entire list only one time, so our time complexity is going to be big O of n. So now let us go to the Python implementation. Now let me initialize a variable called goal, and the value is going to be length of nums minus 1, and let me run a for loop. So for I in range length of nums minus 1, we are going to end it at minus 1, and our step is also going to be minus 1. So if I plus nums of I is going to be greater or equal to goal, in that case we are going to make the goal value equal to I. If goal equal to 0, so it has reached to the initial index, then we are going to return true, else return false. Let me run the code. As you could see, it got submitted for the public test cases. Let me click on submit. And as you could see, it got submitted successfully. It is beating 86.21% of the submission, which is pretty good because it's running at a time complexity of big O of n. That's all for this video. See you in the next one.